Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and I'm also an AWS ambassador. And welcome back to the StratusGrid video channel. Thanks so much for joining us for another video on the Amazon Web Services Cloud platform. Before we get into today's topic, I wanted to talk a little bit about StratusGrid. So StratusGrid is an AWS Premier Consulting partner. We're also an independent software vendor. We have a software solution called Stratosphere available at stratosphere.app. And you can learn more about this at our website at stratusgrid.com as well. But essentially what Stratosphere is it's a FinOps cost optimization tool that allows you to identify cost savings across your entire AWS environment. You can even onboard multiple separate AWS accounts and AWS organizations into Stratosphere so you can get centralized visibility across all those different environments. And then you can actually see some of the cost savings opportunities that are available on different resources that are either over provisioned or idle inside of your account that are good candidates for cleanup to reduce your overall cloud spend without impacting any of the workloads that are running inside of your AWS environment. Now, to introduce the topic for today's video, we're going to be talking about a feature that's been around for about 10 years at this point, which is the Amazon VPC flow logs feature. Now, this was released back on June 10th of 2015 originally. And essentially what VPC flow logs allows you to do is to identify network traffic that is outbound egress or inbound ingress into your VPC environments on your Elastic network interfaces. Now, a lot of different services inside of the Amazon Web Services cloud environment use ENI's Elastic network interfaces in order to attach themselves to your existing VPC subnets. So there's services like, of course, Amazon EC2 instances that will create an ENI and attach that to your VPC so that your EC2 instances and other services can communicate with each other on your VPC. There's also managed services from AWS, things like RDS or Elasticache or AWS Lambda or ECS Fargate and things of that nature. Even things like load balancers and NAT gateways will also create ENIs as well. And again, those Elastic network interfaces are basically just virtual network adapters, just like you would have in a physical computer, but just a virtualized software representation of that resource. And it attaches to the VPC, and then it gets an IP address on that VPC, and then all of your different workloads are able to communicate with each other. So this feature has been around for quite a long time. It hasn't really seen a whole lot of changes over the years, but there is a relatively new feature. It basically extends the log information that's gathered from VPC flow logs to include some metadata about Elastic Container Service tasks. So if you're using either an ECS cluster that you are self-managing with EC2 capacity attached to it, or if you are using the AWS Fargate service that manages the compute capacity for you, then if you're spinning up those types of container-based workloads, you can actually have your VPC flow log include additional metadata about the ECS tasks that you're launching, like what cluster they're running on, what the task ID is, and other types of metadata fields. Now, if we take a look at the documentation here for the VPC service, we can actually see some of the different fields that are being recorded into our VPC flow logs. So if we go to the monitoring section here in the VPC docs and then go down to flow logs and then flow log records, you can see the default format here and the available fields. And the original version of the VPC flow logs that was available was version 2 here. So if you were to spin up something like an EC2 instance, for example, it's going to just emit V2 logs here. But if you take a look further down, there are actually newer versions as well, like version 3, version 4, 5, 6, 7, and even 8 down at the bottom here. Now, the new ECS metadata fields that have been added are version 7 right here. So you can see that ECS tacks on a whole bunch of additional metadata, like what is the cluster name, what is the container instance ARN if you're using the ECS cluster where you actually manage your own EC2 instance capacity. It also gives you the container ID. It gives you the ECS service name if you're using a service controller to spin up your tasks. It also tells you which task definition was used to launch that particular task. And it also gives you the individual task ARNs and the task IDs. So if you need to be able to narrow down network traffic to a particular container-based workload, all of these additional fields that ECS provides on top of the core fields is very useful. But the core fields themselves are really fundamental networking fields, things like, hey, what is the account ID where the network traffic was logged from? What is the Elastic Network Interface ID that the traffic was recorded from? That can help you to tie it back to a specific ECS task or a specific EC2 instance or an RDS cluster or things like that. It also tells you really basic things like the source and destination network addresses. So this could be an IPv4 or IPv6 network address that the traffic is being sourced or targeted to. It also has the source port and destination port at the TCP or UDP layer 4 in the OSI model. It also tells you what the protocol is. So was it TCP? Was it UDP traffic? Is it ICMP traffic? Things like that. It tells you how many network packets were discovered during that flow. It also tells you the number of bytes that were transferred. However, I do want to point out that the actual payload of the network packets is not included in this logging here. This is simply giving you some metadata about the actual payload, not the payload itself, right? It also gives you some timestamp information about when that specific flow started and ended. And it also tells you if the traffic was accepted or if it was rejected based off of something like a network ACL or a security group that is associated with your particular workloads. So a lot of these fields here can help you to answer common questions about your network environment. For example, you might want to filter all of this data, this flow log data that you're gathering, and ask security questions about it. For example, hey, what are all the unique IP addresses that are attempting to access the SSH port on my EC2 instances, right? I want to make sure that any of the source IP addresses that inbound SSH connections are being made from are not potentially malicious IP addresses that are on a very well-known blacklist, right? Something else you might want to know is for something like detecting a botnet or a backdoor inside of one of your application workloads is, hey, what are all of the destination IP addresses that my different workloads are attempting to access? And I can compare the destination IP address right down here, the destination address field, against a known blacklist and say, hey, are any of the workloads inside of my VPC environment attempting to make outbound connections to these known malicious IP addresses? And then that can help you to narrow down potential botnet actors that are operating inside of your VPC environment. And then something else you might need to do for troubleshooting purposes is to determine if network traffic is being rejected by a particular security group. And to do that, you can take a look at the field that tells you if it's been accepted or rejected down here, and that will allow you to determine if you have something configured at the VPC layer that is rejecting network traffic, and then you can go in and configure those security group rules or network ACL rules in order to allow that network traffic through so that you can allow known non-malicious workloads through your VPC environment. So there's a lot of different questions that you might have about kind of the different network traffic that's flowing in and out of your VPC environment. And by enabling VPC flow logs, you can gather all of that data, and then you can use a few different mechanisms to actually filter and query that data. Now, some of the different destinations that are supported by VPC flow logs are Amazon CloudWatch logs. So you can send the flow log data directly to a CloudWatch log group. And then inside of the log group, it actually creates a log stream for each of the Elastic Network Interface IDs that is capturing network traffic in your environment. You can also publish data directly to the Amazon S3 service. So you can create an S3 bucket, and then the flow logs service will go ahead and just spit out all of that flow log data into your S3 bucket in a structured format that you can then query with the Amazon Athena service. And then you also have the option to publish to what's called Kinesis Data Firehose. And if you choose to publish to a Kinesis Firehose stream, then you have the option to transform that data and then forward it to a storage mechanism like S3, a Redshift cluster, or an Amazon OpenSearch database as well. So you have several different mechanisms that you can use to actually store your data and then query it later on. So we're going to take a look at a couple of options here. So the first one is going to be the CloudWatch Logs service. This is pretty easy just because CloudWatch Logs is a managed service. It's there to store generic log data. It's a pretty sensible location to store data. There is a cost to store log data, so you'll want to take a look at the pricing for the CloudWatch Log service and make sure that you kind of estimate how much data you think you'll be storing in there, and maybe take a sampling so that you can kind of calculate out over a period of time how much data you'll actually be storing in there over, let's say, a month or a year's worth of time. But CloudWatch Logs does have the ability to trim data as well, so you can set a retention policy on your CloudWatch log groups, and it'll automatically prune any CloudWatch logs that are older than the retention period that you specify on them. So we'll take a look at how to set that up, and we'll also take a look at how to publish to an Amazon S3 bucket as well. That's another great option for storing and then querying data. S3 is generally pretty low-cost storage, and as I mentioned just a minute ago, you can actually use the Amazon Athena service to query the data inside of this S3 bucket once you've got the data stored inside of there as well. So let's go ahead and actually take a look at the AWS Management Console over here, and we are going to go ahead and activate this feature on a VPC, and then we will take a look at the data and kind of look through the different fields that we talked about in the documentation, and that'll give us a better understanding of what the actual flow log schema looks like and how you can potentially query that data. So for starters here, I have an AWS account. So of course, if you're following along, you want to have an AWS account of your own. And I also have an existing VPC here. And inside of this VPC, I have several different subnets here. I have some public subnets. I do, of course, have an internet gateway attached as well. So I can deploy resources into those public subnets that have publicly routable IPv4 addresses on them. So if you want to set up your own VPC environment as well, you can go up to the VPC dashboard, use the Create VPC wizard here. That will automatically create your VPC and subnets and route tables and your internet gateway, your NAT gateway, and all of that fun stuff. But I'm going to just be using an existing VPC that I have here. Now, there's a few different places where you can apply flow logs. You can apply it at the entire VPC layer. You can also apply it to individual subnets here. So if I go to a subnet, I have the flow logs tab right down here where I can choose to create a flow log. And you also have the option to create a flow log on a specific ENI or Elastic Network Interface. But because I have not yet spun up an EC2 instance, I don't have an ENI to create a flow log on. So to have the most broad capturing abilities here, I'm going to go ahead and just create it at the VPC level. And then that way I can deploy an EC2 instance or a Fargate task or a Lambda function or any other type of service into a VPC subnet. And as long as that subnet belongs to my VPC, it will be included in the flow. So let's go ahead and switch over to the flow logs tab on my selected VPC right here. And I'll click on Create Flow Log. And I'll just call this Trevor01-YouTube. And then for the filter here, you can choose if you want to capture only accepted traffic, only rejected traffic, or if you want to capture all flow logs. So I'm just going to choose all flow logs here so I get the widest or broadest selection of network traffic here. I'm also going to choose the aggregation interval of 1 minute. That'll allow me to get packet captures faster, but you can also choose to aggregate your packet captures into 10-minute segments as well. And then down for the destination here, you have a radio button that allows you to choose several different destinations. So like we talked about, there's the CloudWatch log service, the S3 bucket option, as well as Kinesis Data Firehose. And with Firehose, you can actually store into a Firehose data stream in a different account if you'd like to. So that's definitely an option as well. But for now, I'm just going to choose to send to CloudWatch logs. Now, if you choose to go the CloudWatch logs option here, for storage, you're going to need to choose a service role down here that has permission to create a log group, create a log stream, and actually write data records into that log stream. So you'll actually have to create an IAM role. So if we go over to the IAM service right over here, there is a document here in the documentation for the VPC service that talks about how to set up the IAM role for publishing flow logs to the CloudWatch logs service. So as you can see, there is a policy right here that has the necessary permissions, and then there is a trust relationship here that allows the VPC flow logs backend service, the managed service in the AWS data centers, to utilize this role for this particular purpose. So we need to configure those two things on the IAM role. So I'm going to go ahead and just click the copy button here to copy the policy as well as the trust relationship. And then we'll head over to the IAM dashboard and we'll click on create a new role. We're going to choose a custom trust policy here. And then we're going to paste in the trust relationship there for the trust policy. And we'll go ahead and hit next here. And then for permissions policies, I'm just going to go ahead and skip over that. And then let's give this role a name called Trevor VPC flow logs -YouTube. And then I'll go ahead and just add an owner tag here so my teammates know who is using this role. And then I'll hit create role. And then we're going to click on view role, and we need to add the permissions policy with the specified permissions. So I'll just create an inline policy for now. And then I'll go ahead and choose the JSON option here. And then I can just go ahead and paste in the permissions right here that we copied to our clipboard. And we'll go ahead and just give it a policy name like CloudWatch logs. Doesn't really matter what you call that, as long as it's unique within the IAM role here. All right, so now we've got our IAM role set up with the trust relationship here that allows VPC flow logs to use it, as well as the specific permissions that we need. And then we can go ahead and use that role from the VPC flow logs over here. So let's go ahead and select that service role and click the refresh button here first. And let's search for flow logs, and we'll choose the flow logs YouTube role down here. And then for the destination log group, we can just specify any log group that we want. So let's do /Trevor/VPC flow logs -YouTube. And then the service will create that flow or that CloudWatch log group for me. And then for the log record format, we'll just choose to use the default format here. And we can also check the box here to include the Amazon ECS metadata as well. So we'll go ahead and click on create flow log. And so now for this VPC, if we click on the flow logs tab, you can see that we've created this flow log. Now, do keep in mind that once you've created the flow log, you cannot change the parameters on it. So if I try to click on actions here, I can't edit the log group, I can't change the destination, I can't edit the filter here or anything like that. So all of that is set in stone, but you can always just delete that flow log and then create a brand new one if you would like to. So now that we've got the flow log set up with the CloudWatch IAM role, let's go ahead and actually spin up a workload. So I'm going to go over to the EC2 console here, and we're just going to launch an EC2 instance. So I'll go to EC2 instances and then say launch an instance. I'll just call this Trevor01-VPC flow logs-YouTube. And then for the image, we'll use the Ubuntu image here. For my instance type, T3 micro, doesn't really matter what instance type you select there. I'm going to choose an SSH key pair so I can SSH into that EC2 instance. And then for my VPC, remember that we created the flow log on my Trevor VPC right here. So I'm going to choose that VPC and just deploy into one of my public subnets here. It doesn't really matter which availability zone I choose here because we are capturing flow logs for all of the subnets in this VPC. So then I'll choose a existing security group here. So I'll just choose my default and SSH one right here. And then for the advanced details, I'll go ahead and just choose a spot instance here that will get me some discounted spend on this instance. I'll change it to persistent and change the interruption behavior to stop. And then we'll go ahead and launch the instance. All right, so now we've got this new EC2 instance that is going to spin up here. It should only take a second, but if we go to the networking section over here, you can see that this EC2 instance is attached to the VPC right over here in this particular subnet ID. And if we scroll down a little further, you can see that it has an ENI or Elastic Network Interface that's been attached to this EC2 instance. So that ENI, because it belongs to the VPC, that we created our flow log on, this ENI will definitely be capturing flow logs. So now what I can do is just try to SSH into that server. So let's go to the IPv6 address right here. And then I'll go ahead and just SSH from this shell right here. So let's say SSH Ubuntu at this address. And now you can see I'm successfully logged in here. And so one of the things that I'll do is just install a really simple application on here. So let's do a sudo apt update, sudo apt install docker.io --yes. And then what I'm going to do is just spin up a really basic Nginx web server on here just so that we can test executing some network connectivity to it. And to do that, we'll use the Docker engine just to spin up an Nginx container. And if you're curious, there is over on the Docker Hub, if we go to hub.docker.com, there is an Nginx container image out here that you can use. So let's just do a search for Nginx, and you can see that we've got this Nginx repository right here. So that's the container image that we're going to be using to launch a container on here. It's pretty straightforward. It just serves up a static web page by default. All right, so let's go ahead and do a sudo docker run --detach, and we'll say --net host to attach the container directly to the host's network interface so that we don't have to do any port mappings. And then we'll just specify Nginx, and we'll also do --restart always, just so if for some reason it were to crash, it'll automatically restart that container. So it'll go ahead and download the container image, and then it will launch a new container. And you can also test this locally if we just do curl http localhost. You can see that we get the Nginx landing page right here. And if we go to this IP address of this server, let me do ipadder here and grab that IPv6 address again, which is right here, I believe. Let's go ahead and copy that. And then we will go ahead and try to go to that in our browser here. And let's put an HTTP in front of that. And I think we have to put it in square brackets as well. So as you can see, we just get this standard Nginx landing page. All right, so now we've validated that we are able to access this endpoint here. You could also use the IPv4 endpoint as well. So we could try the IPv4 address here and just do HTTP on that IPv4 address, and it works both over IPv4 as well as IPv6. All right, so now that we've done that and generated some network traffic, we can go ahead and go over to the console again, and we'll go to the CloudWatch service here. And now we want to go to CloudWatch log groups, and under CloudWatch log groups here, we can just search for flow. You can see we've got Trevor VPC flow logs -YouTube right here. And then for the log streams right here, this log stream ID actually aligns to the ENI that we attached to our EC2 instance that was created when we launched it, right? So now you can see that we've got all these logs here. You can see all of this IPv4 traffic, IPv6 traffic, and things like that. And it starts at the oldest entry up top, and it progressively gets newer as we go further down. So all this network traffic here, when the instance was originally spun up, you can see is making various connections right here. So we can see the version of the flow logs, which is version 7. And so the version 7 of the flow logs is going to contain these additional ECS fields right over here. We also have the AWS account ID, the ENI ID. We have the source and destination IP addresses. We have the source and destination ports here as well. We also have some additional fields here that tell us like the type of traffic and things like that. We also see if the packet was allowed or rejected, and the log status field here. Now, if we wanted to, we could actually filter this data by going into the documentation here, and then we can do a search for the document called search flow log records right here. And then we can copy this pre-built filter right here. And this basically just establishes the schema of the data fields. And what we can do is paste that into the filter here. And by default, there are no filters specified. But what we can do is change the criteria here to filter to specific fields. So if we wanted to filter for accepted or rejected traffic, we could simply find the action field right here and then add criteria that says equals reject, and hit enter. And that will now filter only to rejected packets here. If we want to change it over to accepted, we can simply change it to action equals accept, hit enter, and now you can see that we get filtered to the accepted network packets here instead. So you can use the other types of CloudWatch filters here. There's additional documentation in the CloudWatch log service that talks about how to specify these filters, but that's just a really basic way for us to filter for something like the action if it was accepted or rejected. All right, so now that we've figured out how to really basically configure the VPC flow logs here to log to the CloudWatch logs service and then filter that data, let's also talk about how to send this data to the Amazon S3 service as well. So what we'll do is head back over to the VPC console over here. And this time we're going to be publishing to S3. We don't have to create an IAM role this time. It'll just be able to publish to S3 for us without creating an IAM role. So once again, we'll go over to our VPC right here. And I'm actually going to create an S3 bucket at first. So let's go to the S3 console. And we'll go ahead and just create a new bucket in the same region. And we'll call this Trevor-VPC flow logs YouTube, and then we can go ahead and just create that bucket. And let me copy that bucket name to my clipboard here so I don't forget it. And then we'll come back over to VPC. We'll go back to flow logs once again and say create a flow log. And then we'll go ahead and paste in or actually not right there. Sorry, that's just the flow log name. So we'll say Trevor01-S3. We'll choose all traffic. We'll choose a 1-minute aggregation interval. Then we'll choose send to S3, and then we can specify the ARN of the S3 bucket. So let me actually open up the console here again, and let's do a search for VPC flow logs. And there should be an option to copy the ARN of the bucket somewhere right here. So over on the Properties tab, you can just click the copy button on the ARN attribute right there, and then we can come back over to VPC and just paste that in. You can also tack on an additional prefix that you want to use. So I could just say, I want this to go under VPC flow logs / my VPC or something like that. You can specify any custom prefix, or you can just tell it to go to the root of that S3 bucket as well. I'll choose to include Amazon ECS metadata this time again, so it includes those additional fields. And this time, because we're going to S3, I'm going to choose the Parquet option, and I'm also going to choose the checkbox down here to use Hive-compatible S3 prefixes. And then you can choose the partition, and I'm going to choose partition by hour. All right, so let's go ahead and create that flow log here. And then once that flow log is created, we'll go ahead and just generate some more network traffic. So let's go ahead and grab the IP address of this instance again. And we'll go ahead and open that up. So let's go to, not that page, but Nginx right here. So we'll go ahead and just refresh this Nginx page a couple of times to reinitiate some network traffic. Looks like maybe I have the wrong IP there. So let me go to EC2. Actually, no, it looks like that's coming up correctly there. So it's just being a little bit slow. Let me just validate that over here, though. So we'll grab the IP address and go to there, and there it is. Okay, so if we just refresh this a few times to generate some new network packets, that should generate some activity. And then if we go over to the S3 service here, we should see some data start to pop into that S3 bucket. And then to query that data, we can actually use the Amazon Athena service. So let me search for VPC here again, and we'll grab this bucket. And you can see that it's created this key structure here. So we've got these prefixes, AWS logs, and then the AWS account ID. And then eventually we will see the objects start to populate into here under additional prefixes. So now you can see that we've got these additional prefixes here. So you can see the AWS service ID right here. You can also see the region prefix. You can see the year prefix, month, day, and hour as well. So now you can see we've got these Parquet files here. And so you could optionally just download this file locally and process that using some kind of local tooling on your development system. But another option that's available in AWS is to simply query that data using the Amazon Athena service. So what we'll do here is go back to the documentation for the VPC flow logs here. And then if we go down to view flow log records with Amazon S3, you can see there's a link to the Athena documentation here called Querying VPC Flow Logs. So what we're going to do is go over to the documentation where it says use Parquet right here, and we are going to create an Athena table based on this data definition language right here. And then all we need to do is override the location where the data actually resides. And so all we need to do is specify the bucket and any additional prefix that we may have included. Of course, in my case, I didn't include any prefix on there. So all we need to do is specify the bucket ID, and then it will partition the table, and then we can start to query that data with the Athena service. So what we'll do is head over to the Athena console here. So let's go to Unified Search and then look for Athena right up here. And then in Athena here, if you are using Athena for one of the first times, you'll need to specify a query result location here. And this is basically just a bucket where your query results will actually get stored when you execute them. And typically you'll see a prompt to do that. But what we're going to do is go over to the query editor here, and we're going to paste in this query that we copied from the Athena documentation. And then down here for the location, we're going to specify the bucket where we put our logs. And so that is going to be the bucket right down here. So I'll go ahead and just paste that in. And now we can go ahead and run this query to create the necessary VPC flow logs table. As you can see in the current default database, there is not a table called VPC flow logs Parquet. So we'll go ahead and run that query to create the Athena table. And then after that Athena table has been created, there is one other command that we'll need to run to actually load the data from S3. And so what you'll see right here is the schema of that table. So the version field is an integer, the account ID is a string, interface ID is a string as well, and so on and so forth. So this just defines all the different fields inside of our flow logs. But what we also need to do is go back to this document and copy this msck command down here, and then we'll go ahead and run that in here as well. So let's add a new query editor and run this query. And then after we run that query, we should be able to just select data from this table. So one of the things you can do is just click on the triple dots next to the table and click on Preview Table, and that should show you some of the results from that table now. So now that we've got the data available to us, we can start to do additional queries. So what we could do is say, hey, I want to select all fields from this Athena table where something like, let's say the source port field is equal to a certain value, or let's say maybe destination port is equal to 22. And then we can go ahead and run that, and you'll see that there are no results there. But if we change the destination port to something like 80 and rerun that, now you can see that we actually do have some network traffic here. So this allows us to identify traffic that matches certain criteria here. We could also say something like, hey, I want to see any traffic where the action is equal to reject. And we could go ahead and run that. And it looks like that's not going to allow it based on the syntax here. So let me figure that out really quick. And I think I actually need to use single quotes here instead in this query. So let me try using single quotes there. And so, yeah, that works here. And so now we can just see any network traffic that has been rejected. And so I can look through this network traffic. I can see what the destination port of that traffic was. And if that's network traffic that should have actually been allowed, I can use this information to figure out which network security group I need to go open up and allow that network traffic through. So as you can see, there are a couple of different ways that we can capture our VPC flow logs. We can capture it into the CloudWatch log service. We can capture it into Amazon S3. We can also use the Kinesis Data Firehose service, which is a little bit more of an advanced use case, but you can actually do some inline transformations on your data in Firehose, and then you can send it off to several other destinations like Redshift clusters and the Amazon OpenSearch service as well. So it's really up to you where you want to store the data, but you can create flow logs at several different levels. You can create it at the VPC level, you can create it on individual subnets, or even on individual ENIs as well. Now, one thing I did want to mention to you is that so far we have seen all of the additional ECS metadata fields are currently empty, and I'm not sure if we have them in here at the moment. Let's go ahead and scroll down here in our schema, but we did see them showing up in the CloudWatch logs service. So it looks like the schema that we defined here from the documentation does not include those fields, but I did want to show you that over in the CloudWatch logs service, we did actually technically have placeholders for those fields. So let's go back over to our log groups here in CloudWatch. We'll search for VPC flow logs down here. We'll go down to our ENI log stream here. And if we open up one of these entries here, you can see all of these additional dashes at the end here. So those are all of those extra fields in version 7 of the flow logging design schema. And those are all empty because right now that network traffic is coming from an EC2 instance, and therefore the ECS service just doesn't have any additional metadata to add to those fields, right? So I did want to show you what it actually looks like if we were to spin up an ECS task. So what we'll do is head over to the Elastic Container Service over here, and you'll want to create a cluster here. It doesn't actually have any EC2 instances associated with it when you're using the Fargate launch type, but you do still have to technically create a cluster there. And then I have an existing Nginx task definition that you can create in here. So the task definition basically just launches a new Nginx container, and it sets up the container port mapping so that we can access port 80 on it. So I'm going to use this task definition that I've already pre-created to launch an Nginx Fargate task running as a container in ECS, and then we'll see all of that additional metadata showing up inside of our CloudWatch logs. So what we'll do is go to ECS here into our cluster, and then we'll go to the tasks section here to run a standalone task and click on Run a New Task. And then for our task definition family, I'm going to choose my Nginx task definition family with the latest revision here. Under the networking section, I'm going to choose my VPC as well. And then I'm going to choose a specific public subnet to deploy into. So let's choose this one right here. And then for my security groups, I want to choose a security group that already has an inbound TCP port 80 being allowed, which I believe this default one does. So I'll go ahead and just leave that there. And then I'll go ahead and click on Create Task. So now that will launch a new Fargate task into my cluster here. As you can see, it's currently in the provisioning state right here. And in just a moment, after this is up and running, we can see under the networking section right here that a new Elastic Network interface with a unique ID has been attached to that ECS task. And that is what's going to show up in our CloudWatch log group as a log stream. And that is the new log stream that we're going to want to look at in order to see network traffic from here. So let's grab the public IP of this task and go ahead and just try to access it in our browser here. And sure enough, we just get the Nginx landing page right here. So we've generated a little bit of network traffic to it. I'll just refresh that a few times in the browser to make sure. And then back in the CloudWatch console here, if we go back to the log group, the parent log group, you can see that I now have a second log stream right here with the ENI 0605, which aligns to the ENI 0605 that I have on my ECS task right here. So if I open up that new log stream here and take a look at the log messages here, you can see that I have these additional ECS fields that are associated with each of the flow logs here. So I can see exactly which task definition was used to launch this task. I can see which ECS cluster in my account and region is being used to run that task. So if I need to go narrow it down, I can go directly to that specific cluster. And then I also can see specifically which task ID is being used to generate this particular traffic flow. So this task ID right here, 4FC4, is the task ID of this task that's running on this ECS cluster called Trevor-Fargate here. So this allows me to directly correlate potentially malicious network traffic back to a very specific container-based application that's running inside of the Elastic Container Service inside of my AWS account. So that additional metadata is extremely helpful. It would be really nice in the future to see metadata like that from other services like RDS or Lambda and other supported services for flow logs. But for now, ECS is the only service that has that extended metadata available for it. So feel free to enable that and just make sure that when you create your flow log that you do actually activate that option. So back when we create a new VPC flow log here, we did have to check that additional box here to include the extra ECS metadata fields in order for those to show up in our CloudWatch logs log streams. All right, so I think that's everything that I had for this video. Hopefully you learned something new. Please leave a like on the video and also subscribe to the channel and check out all of our historical videos and check out all the different AWS topics that we have. There's lots of other interesting AWS topics available on our channel. Also, leave a comment down below and let us know what you thought of this video, and keep an eye on our channel for future videos. Thanks again for watching. I'm Trevor Sullivan, a solutions architect and AWS ambassador. Take care.